So the last few days we've been talking about factoring and turning factored form into standard form and vice versa. So now we're actually going to look at more modeling with quadratics or parabolas in a sense. So which of these following triangles has the largest perimeter? I want you to take a guess. I'm going to say C. Why not? When you click your option, you're going to hit the next button. And you're gonna put these triangles in order by area. So the greatest area to the least area. I obviously said A. I think that looks great. I'm gonna go with CBA, cab. You can go with whatever you think. So the next slide we can see we have it's all the same perimeter. Now if you remember perimeter, you add up all the sides. So since they're all the same, I'm going to add 20 plus 20 plus 5 plus 5. And I should get a perimeter of 50. So 10 plus 10 is 20, plus 30 is also 50. 4 plus 4 is 8. 8 plus 21 plus 21 would give me 50 as well. So I'm going to hit submit and hit the next button. Another fun fact, they all don't have the same area. So which one has the greatest area? So remember, area is length times width. So 20 times 5 is going to give me 100. And 10 times 15 is going to give me 150. And 21 times 4 is going to give me 84. So it looks like a B has the greatest one, and it is 150. When you share it with the class, you'll see other responses. But if we move to slide 5, it says build a field. You're going to build a field here, and you can use 50 meters of fencing, only 50. So what you're going to do is you're going to grab the corner here, and you're going to make it exactly 50 meters of fencing. So I'm going to go all the way down here, and I'm going to make it wide. Why not? Oh, perfect. So I'm going to build field A. So field A, I'm going to match with the other fields. Now I'm going to do the same thing, but field B. Make it a different one than my last one. So I'm just going to go straight out and do super wide. And honestly, you can have different ones. There's my field B. Now I'm going to do C. It says make the field C as big as possible. All right then. Well, I I guess B was actually supposed to be the biggest one, but that's okay. That's alright. So there's my 3 fences. 3 options. If you click the next button, we're going to calculate the area of all of our fields. So the length is 2. The width is something. My perimeter is 50. So I need to know this. What I need to figure out is my width. So I actually do need to get a piece of paper out. So remember the formula for perimeter is 2 length plus 2 width, or length plus width plus width. So I know my length is 2, it says it right there. So I have 2 plus 2 plus, I'm going to combine these two together, 2W equals 50. So I need to figure out the width. If I combine these two, now I have 4 plus 2W. And now I have a 2-step equation. I need to get the W by itself so I can figure it out. What I need to do is subtract 4 from 50, and these cancel. I bring down my 2W. 50 minus 4 is going to give me 46. And if I divide it by 2, I'm going to get, 23. So my width for the first one is 23. I can do the same process for the other ones. It's just in this case, instead of having 4, I'm going to have 13 twice. So 13 times 2, we'll use the other formula. So 13 times 2 is going to give me 26 plus 2w equals 50. And again, following the same process to get that 2w by itself. So 50 minus 26 is going to give me 24. Sorry, that's a 6. And if I divide this by 24, w equals 12. So this one is 12. And then I have 23. Now I have 2 times 23, because there's 2 sides that are 23. And 23 times 2 is going to give me 46, plus 2w equals 50. Again, get rid of the 46. And what we get is 4, 2w. 4 divided by 2 is going to give us 2. Oh, look, it was right there. That's okay. So now the area, I'm going to take my width and multiply it by my length. So 23 times 2 is going to give me 46. 13 times 12. 13 times 12 is going to give me 156. And 23 times 2 is going to give me 46. So once you enter those numbers in, they will stay as is. So now it says for slide 7, sketch the relationship. Imagine that we're looking at your classmates' fields. So these are everybody's fields. Now imagine we've made a graph of those areas, fields, against their length. Sketch what you think the graph would look like and or describe it below. So I'm going to let you decide how you would like to draw this. I'll give you a moment. Obviously, here we would have a bunch of different people's areas. You would have something like this. You know, random dots, especially from your classmates. And since I'm doing this early, it's not going to have an effect. But what we're kind of seeing is what it should look like is roughly a parabola. And honestly, it could concave up or down, just depending on, of course, how the class draws their rectangles from before. So we're going to have roughly a parabola. And if you hit submit, now it's actually going to show just my points again for this one, but what you can see here is the graph shows the fields of classmates created today. Ours are the orange points. Obviously, you would see everybody else's around it. What function do you best describes the data? So just with my points, I can't make a linear line because all of my points aren't in a straight line, or at least a straighter line. Exponential, it could be, but here's the thing, if I had more points, I could see that it wouldn't be exponential, just because it's not increasing different amounts each time. See, if I had a quadratic, and let me go back to the last slide and draw a quadratic to remind you. A quadratic formula looks something like this, in a sense. It's going to increase super steeply and be constantly increasing. So in this case, it can't be an exponential, so it's going to be a quadratic. And of course, when we actually do this in class, you'll see more points, and you can clearly see that it's curving down, or concave down. So you said it was quadratic function, best represents the data. Drag the green points so that their representations were on the graph. We'll find the larger field. So take a moment and drag anywhere you would find the vertex of our parabola. Now for my graph, my parabola vertex would be about right here, pretty much right where that orange dot was. My parabola would be, because that is the vertex. So what it's really asking is, where is our vertex? Where is the largest field going to be? What's the highest point for our concave down, or our maximum? So what is the area of the old field with 50 meters of perimeter? Show our answer in the table. So we don't necessarily know what that field was. But what I do know is if it's evenly distributed, we would know the width would be 25 minus our length. Because we don't know what the length is, but we can take a darn good guess and say that the width is 25. Whatever 25 minus x is going to give us our width. Therefore, it would give us our length, because I know that the perimeter, if all the sides are the same, and in this case they're not, just these two sides, the x sides are the same, and the non-x sides are the same. So then, that means for our area, it's actually going to be x parentheses 25 minus x. And the reason why, again, is length, which is our x, times our width, which is 25 minus x. So now here is the graph of our function. What does this tell you about the dimensions of the field with the most area? So what is it telling us our maximum is? Well, we can look up here at our point and see what our maximum is, which is going to be right about there, right in the center. So I was a little bit off with my vertex. So our center, our vertex is 12.5 and 12.5 length and 156.25 area. So that is on average what our what the highest field can be is 12.5 by 12.5 for the length with an area of 156.25. So length is 12.5 is the highest, and our greatest area is 156.25. Then once you hit share with class, we'll be able to see your answer. So let's say you have 50 meters of fencing and you have 60 meters instead, or 600 meters, or an infinite number of meters. I want you to try to figure out, write instructions for how to find the dimensions of our biggest field. So just like what we did in class today. We found the vertex. Find the vertex using the formula. Yeah. And I think the last one, yep. So imagine you have 50 meters of fencing again, but you're building a long wall. You'll need 3 sizes of fencing. So create 3 sizes of fencing with meters of 50 fencing again.